Hello everyone. Today I'd like to start by talking about the primitive data types available in Python. Hopefully this is going to be a short to the point video that describes the primitives. Last video I finished it by showing an anomaly when I was doubling a number. Instead of actually doubling it, it seemed like it was repeating it. It connects to what I am doing today somewhat, but the exact explanation of what happens is going to come in the next one as we go to more container data or object data. So instead of essentially showing you a slideshow, I thought it would be better for me to just simply develop a program right off the bat and contain all the information. So sorry, let me first okay, so let's start writing a program. Let's PrimitiveTypes.py. So primitive data types. Primitive data types are simply data that have no additional components to them. They're just a number and nothing else. And there are really four different types that I want to show today. Actually, there are four that I want to mention, three that I want to briefly explain, and then from that point forward, we're going to go into the more complex data sets. So these four include integers, floats, which are also called real numbers, Boolean, which are either true, false in value, and also complex numbers. So Python also has complex numbers, but for our purposes, I'm not going to really worry. So complex numbers are interesting. Not many other high-end programming languages actually have complex numbers. C++, Java, they all have integers, floats, booleans, and in fact, extended versions of integers, short, long, and so on and so forth. Whereas because of the automatic typing of Python, those are unneeded. But Python also has this complex numbers that actually makes things simple for advanced algebra, but I'm not going to cover it here. Complex numbers are used in very specific arenas of mathematics and applications, so I'm not going to really worry about it right now. As I said before, the best way to develop a program is to do it incrementally. So here's a program, again, a whole bunch of print statements that echo the information that I have asked the program to do. Now, integers. Sorry, no semicolon needed. Maybe that should be a logo for Python. Something I introduced last time, I want to expand on today. So a programming environment, it may start by prompting the user to receive some information. It will receive the information, will process the information in a useful manner, and it's going to echo the results onto the screen or to some sort of an output device for the user. So we kind of know print statement, we kind of know input statement. But what we haven't covered is what happens in the middle. In the middle and between receiving an information from the user and in trying to process it, there needs to be intermediate storage elements used in order to store the information that the user has provided, manipulate it in order to achieve the objective of the programming. Now, these storage devices, they can be complex storage, data complexes, the data structures, or it can be primitive data structures. So the primitives are the ones that we're going to cover today. And these storage compartments, we call them variables, and variables usually, we give them meaningful names. So in here, I'm just going to use variables ABC. People can use X, Y, Z. So generally, what is typical in the field is letters A, B, C, I, J, K, L, M. Those usually go with integer numbers, where variable names X, Y, Z usually go with real numbers. But the better thing is to come up with a variable name that's descriptive of the function of that variable. So for example, I want to receive age from a person to do something with their age. It would be very useful for that variable that's going to contain the information regarding age just to be called age. Don't call it A, don't call it B, don't call it C. Make your program more readable by making variable names to be relevant to the information that it is containing. Here I'm performing meaningless tasks, so therefore I'm going to just use ABC. So A is my variable name, and I'm going to assign to it an integer value. The reason it is going to be integer is not because I have specified so. In other programming language, I would have said integer A equals to 10, and it would be explicitly defined that I want it to be integer. But in Python, it's actually typed automatically. So if I include a 10 in here, an integer number, a whole number, then Python is going to interpret that to be an integer, and it's going to assign it as the type of A is an integer. Now, what I can do, I can then print A. Sorry, you can see that it says integer, and it echoes the value of 10 out. I can do a number of things now. I can say 2 times A is an exercise that we did before. It sort of didn't work out. And this time it seems to work. I can perform arithmetic operations. I can say 2 plus A. And it will do the things that we expect to do. So I'm going to just move on, come to some of the more advanced points later. So floats. B is equal to 10, but this time if I leave it as 10, then B is also going to be integer. But to enforce the idea that I want this to be a real number, a float, I am going to put a decimal value to it. Even though from the mathematical perspective, 10 is the same thing as 10.00000, but from the programming environment, the perspective, they are different entities. They require different storage space. They are treated entirely different. And I can now do the same thing, B. And a value of 10 is printed. I can do the same thing as 2 times B. I can do print 2 times B plus 3 times A. And all of these will work as anticipated. So 3 times A was the value of 10. So 3 times 10 is 30 plus 20. 2 times 10 is 50, and 50 will be added. So this is really real numbers. Notice that when it's being printed, real numbers get printed with decimals, whereas integer numbers do not have any decimals by definition, and therefore they're just whole numbers. The other data type are Boolean. And Booleans get, so I'm going to call it C equals either true, in which case if I say C it will get the value of true, or C can be false, in which case when I print the value of C, you will get false. So integers are plus or minus numbers that are whole numbers. Real floats are numbers with decimal places, plus or positive or negative. Boolean, by very definition, they are either true or false. So everything in the world of Boolean is going to be mapped one way or another based on some set of rules to either true or false. Here, what I have shown is explicitly true or false, but you'll see later on that there is a different kind of mapping from numbers to Boolean, which then there are a set of rules used in order to make that mapping. Some additional information about these assignments. So at this point, A is an integer, B is a real number, and C is a Boolean. So I can say at this point, I can say B equals to 22, and, sorry. So B previously up to this point was a real number. As I was printing the value of B, I would have gotten a decimal place out with it, indicating that's it's a Boolean, I'm sorry, it's a real. And somewhere along the line of the program, I basically reassigned B, instead of having a value of 10.0, have a value of 22. And at this point, you can see that the print statement provided 22 without any decimal places. Essentially what happened here is when a new opportunity for assignment and evaluation of B arises, based on the content that's being assigned to B, B will be recognized from this point forward to be an integer, not float anymore. So the type of B is automatically adjusted as the program proceeds. So at this point, while assuming my A, B, and C can be reassigned to be of any type, I can always do the following thing if I wanted to. A, B, C equals 1. Yeah, that's something else actually. Sorry. You can concurrently assign the same number to all three or multiple number of your variables. You can say A equals to B equals to C to 1. So basically a value of 1 will be copied over to all of your variables. You can also do something that I was trying to show you is I'm going to copy these two, place them here. I'm going to do what I was trying to do before. You can assign 3 numbers in one expression to 3 variables. So in here you have variables A, B, and C that are waiting to receive an assignment, a number assigned to them. You need to provide a list of equal size on the other side of the assignment operator 1, 2, and 3 in order to assign things over. This is somewhat unique to Python compared to Java and C++. In addition, what you can do in here is kind of also unique and kind of useful at times. I'm going to do this 2, copy paste it here. What you can do in programming, sometimes we are interested in swapping the value of 2 variables. Something has number 1, something has number 2, and I want 2 go to the first one and 1 go to the second one to swap them around. And for those of you that are familiar, you would need to have a temporary variable assigned, Whereas in here, I'm going to start with A, B, and C containing values of 1, 2, 3. But I can say C, comma, A, comma, B, comma, A. And the numbers will be swapped. And this is a useful feature that can be used a variety of places. It's neat tricks like this, the components of programming language, that makes things readable and makes things a little bit simpler to program. If you wanted to do this, to reassign A, B, and C to each other, you would need to have to go through 3 or 4 lines of code in order to do this in other programming languages. So at this point, what I'm going to do, I'm going to stop. I'm going to, I assume it's clear that with the numerical types, with integer and floats, you can perform all the basic arithmetic operations. What I'm going to do next, I'm going to talk about strings. Numbers in applications to bioinformatics are used, but not as extensively as strings. We are oftentimes in bioinformatics, we are interested in analyzing genomic sequences, which is nothing more than a sequence of characters or a string. So I'm going to switch to strings, and from there I'm going to go to control elements, if, for loop, while loop, and from there, we're going to get into more sophisticated programming constructs. So, thank you, folks.